All right, so we're going to look at horizontal asymptotes and limit notation. So let's talk about what a horizontal asymptote is picture-wise first, and then we'll get into looking at this explanation and the symbolism and stuff that's going on here. So if I have a graph and I have some sort of function, maybe it comes up and down, and then eventually it kind of settles down to about the same value, same y value all the way, then the horizontal asymptote is that horizontal line that it looks like my function is approaching. Okay, so as I go out to infinity, it's just going to kind of hang out right around that line. Okay, so that horizontal asymptote is a horizontal line that your function is approaching as you just keep going out towards infinity, right? So we have this definition here. The horizontal line y equals k, so this is whatever that y value is. So if this happened to be 2, 3, if this was y equals 4, then we would say the equation of this horizontal asymptote is y equals 4. Okay, and we have a horizontal asymptote if the function values, so that's the y values, get close to k, or in this case get close to 4, as x gets large. And that can mean as x goes to infinity, so as we go out this direction. It can also mean as we go to negative infinity. So as we go this way, if the function settles down to something. So let me do that. So maybe it kind of does that. It looks like it's settling down to right about here, okay, on this side of the function. So we can look at this as x goes to positive infinity or as x goes to negative infinity. And we're looking for the y value that it settles down to. All right, so we have some notation for this that is the behavior of y. So we say f of x, or y, which is another name for f of x, goes to k as x goes to infinity. Okay, but we can also sum kind of all of this up, which seems like two disjoint pieces, by saying the limit as x goes to infinity of my function is equal to k. So here, if this is my f of x, as x goes to positive infinity, f of x is equal to 4. Okay, and similarly, we can do this as x goes to negative infinity. So the limit as x goes to negative infinity of f of x, in this case, this looks like it's probably about negative 2. So as x goes to negative infinity, this is going to be equal to negative 2. All right, so let's give this a try. Here I have the limit as x goes to positive infinity. So I'm interested in looking at what this function does as it heads out this direction. And it looks like it's going to settle down right here along the x-axis, which is y is equal to 0. Okay, which means my horizontal asymptote equation here is y is equal to 0. It's whatever that y value is that we're settling down to. All right, number 7, I'm looking at the limit as x goes to negative infinity. So I'm looking at going this direction. And I'm trying to see if f of x settles down to something. So looks like it's kind of leveling out right about here, which is about y is equal to 1. So that limit as x goes to negative infinity of f of x is equal to 1. And that means my horizontal asymptote has an equation of y is equal to 1. Okay. And then last but not least, number 8. So we're looking again as x goes to positive infinity. So I want to see what my function is doing as I head out this direction. And in this case, as I go out this way, this function looks like it's going to infinity and beyond. So we would say that this, usually I turn this into a little arrow here. We're saying that that limit as x goes to infinity, that y is also going to infinity there. And so that means we don't have any horizontal asymptote. Okay? So you only get a horizontal asymptote if your function kind of levels off at some y value.